Micronor announces the arrival of the world's first fiber optic position sensor.
And all optical design makes it 100% immune to any electromagnetic interference. Micronor's novel fiber optic position sensor consists of a sensor and a controller. The system is connected by a duplex fiber optic cable. No electrical connection to the sensor is required. There is one fiber optic strand for transmitting light to the sensor and one fiber optic strand to receive the light with the position information from the sensor. A push-pull fiber connector makes connection to the controller simple. An LED status indicator confirms that the connection to the sensor is completed and that the system is functioning properly. The model MR330 is a true absolute position sensor with an incredible resolution of 13 bits. The controller transmits a burst of light to the sensor. Inside the sensor, a code disk modulates the spectral components of the light. The position information is now imprinted in the optical spectrum of the light and guided back to the controller for position readout. The system keeps accurate track of positions to speeds in excess of 2,500 RPM. This is an absolute position sensor. Single turn with a 360-degree continuous reading. And a resolution of 8,192. It keeps track of speeds in excess of 2,500 RPM. To demonstrate that this sensor is truly absolute and capable of giving accurate readings at startup, we will now power down the system and start it up again. First, note the position readout of 1,457. The field below shows the angle calculated in degrees. Now, we unplug the fiber optic cable, shut down the software, unplug the power to the controller, and remove the serial interface cable. To start up the system again, we plug in the serial interface and restore the 24-volt DC power to the unit. For now, we leave the fiber optic cable unplugged until the readout software is running. While the sensor is disconnected, the maximum readout of 8,191 will appear. Now, we reconnect the optical fiber and the readout will return to the 1,457 position. The sensor will always know its exact position, whether the shaft is stationary or rotating. The controller is powered by a 24-volt DC and consumes only 70 milliamps. Numerous position output interfaces accommodate many applications. The sensor is unaffected by electromagnetic interference, lightning strikes, electrical discharges, energy weapons, magnetic fields from motors, and radiation. The positional information is embedded into the light spectrum and not the amplitude. Thus, it's unaffected by a varying loss in the fiber optic lines. This wave graph shows the reading of the sensor. When the optical power changes, as simulated here by adjusting the connector, one can see a drop in the readout waveform. However, the position reading is not affected at all. Rather than using light intensity, Micronor ingeniously utilizes the light spectrum as an information carrier, making this a very robust position sensor. Again, note that the position readout does not change when the light amplitude is brought back to the previous level. The MR330 is an absolute position sensor, immune to electromagnetic interference. It will not radiate or spark, and operates reliably with fiber optic cable lengths of up to several hundred meters. So when true position is needed, Micronor is the solution.